Okay, we're going to calculate the divergence for the vector field f. Here we've got the vector field, and as defined below is f1, which is x squared e to the yz, f2 y squared plus log xz, and f3 z squared over x plus 2z cubed. So the first thing we need to do is just write out what the divergence of f is, which is the partial differential of f1 with respect to x plus the partial differential of f2 with respect to y, and then finally f3 with respect to z. So we require these three partial derivatives. So firstly we'll take the partial derivatives of f1 with respect to x. Which is equal to the derivative of x squared e yz which as this is the only x squared term, so then we take it to e to the yz times 2x. So our first partial derivative is 2x e to the yz. Second one is f2 with respect to y. Again, we just have one term with y in. As it's added, this one goes to 0, and so we have 2y plus 0, which is 2y. Finally, we need f3 differentiated with respect to z. In this instance, we've got z in the numerator and the denominator of the fraction, and so we need to use the quotient rule. So if we set u is equal to z squared, and v is equal to x plus 2z cubed. Firstly, we will differentiate u with respect to z, which is 2z, and v with respect to z, which is 6z squared. The quotient rule is v du dz in this case minus u dv dz divided by v squared, and so we have x plus 2z cubed times 2z minus z squared times 6z squared divided by x plus 2z cubed squared. This is equal to 2zx minus 2z to the 4 divided by x plus 2z cubed squared. Hence, the divergence of the vector field f is equal to the three terms we have added together. So we have 2x e y to the z plus 2y plus 2zx minus 2z to the 4 divided by x plus 2z cubed squared.